Hello, I'm Jeff Hunt, and this is the fifth episode in my mini-series of the science of water. So I've made these tapes because knowing more about how intricate and complex water is has really helped me to understand building defects better. It pays never to underestimate water, and in this final piece I want to look what happens when water condenses and evaporates. Now, when I've been thinking about this episode, I've wanted to keep it fairly straightforward, and so this particular type of topic can get very complex when you look at the science. So I've simplified the science just to let you appreciate what is happening. Now, I realise there's people out there that know far more than I do about these sorts of things, and so I do apologise to them straight away, as if some aspects have been skirted around. But this is only really to give a bit of clarity. And well, maybe the presentation isn't for you smart ones, but perhaps do please feel free to put comments at the bottom so that we can all benefit from everybody else's experience. Okay, right, let's dive right in and see where we can start. So let's take a look at some very, very basic pictures, which is always a good place to start. And here you can see two drawings of evaporation and condensation. And you need to think of this topic in cycles. But whatever the stage it is, water is moving around, and in each of these phases we can get problems. When water moves from a liquid to a gas, that is obviously called evaporation, and when it turns from gas to a liquid, this is called condensation. So that's all pretty simple so far, isn't it? Well, what we need to look at is the rate at which this cycle takes place and what point it happens. This can help us to understand what it takes to control moisture in our homes. Now, first we need to take a look at the behaviour of the water molecules. And what I've here, I've put a picture of Mr. Tortoise and Mr. Hare. I want you to imagine that those are water molecules. Now, the reason I've done this is because molecules don't all behave the same. We know that molecules move faster when you add more energy to them. But the really clever thing is that they move at different speeds at the same temperature, just like Mr. Hare and Mr. Tortoise. So do you see what I've done there? So some go very, very fast and some go very, very slow, all at the same temperature, which obviously means that some can break free and evaporate way before the others, and conversely, some will condense sooner than others. So I hope you've got this all so far. So you can see this actually when you watch a kettle start to boil. The water starts to steam way before 100 degrees C, and this is the faster molecules breaking away way before the others. And this is why you don't need an air temperature of 100 degrees C to evaporate water out of walls. So yes, water evaporates at its fastest rate at 100 degrees C, but it doesn't need 100 degrees C before it starts. It will simply just evaporate slower at lower temperatures. And the same is true of condensation. It does not all happen at the same temperature. In fact, you might not see anything happening at all. And that really does catch a lot of people out. People think that condensation has to be seen to be dripping off the walls. Well, no, that's really, really not true. Now, I want us to take a look at something else as well, and that is the behaviour of air. So we also need to consider this, and as part of this picture, because we know that warm air can hold more water. Now, I want you to think of warm air as having more space between the molecules that makes up this air, and this hot air balloon is an example of warm air expanding and becoming lighter. So you would think that this space would give more room for the molecules, and that's how it all works. But actually, that's not technically correct. You see, there's plenty of space in water molecules in both warm and cold air. There's plenty of space to go round. So what is happening? Well, in the cooler air, the water molecules making up that air are simply absorbing less energy than they do in warmer air. Then when the water molecules absorb less energy, they are less excited, they move about less and with less force. So they begin to condensate on cooler surfaces with which the air has come into contact. So it's really more about energy absorption and where that energy goes that counts. Now we know that water can consume huge amounts of energy and take it with it when it leaves as water to become a vapour. So it pressurizes the air. And if you want to understand more about the energy that water gives up and decants when it changes from a gas to a liquid, take a look at the series number 4. So you can see that when we look at buildings and see the results of the effects of water in such things as staining, mould growth and rot, we can sometimes forget that the many ways in which water can move through materials. So in the earlier series we talked about gravity and cohesion, and now we have seen that water can do much more besides. And it is this ability of water to contain, move and sustain that makes it our number one candidate for building problems. So in the next series I will move to the significance of the dew point and why, for all our technical knowledge, things might not work out as we might expect in practice. Well, I hope you've liked this series so far, and if you have, please check out in LinkedIn the Reporting and Managing Residential Defects group and my YouTube channel, Residential Surveyor Academy with Jeff Hunt.